Assalamu alaikum wa rahmatullahi wa barakatuh. Dear grade 10 students, we'll continue with our revision of Unit 1, Forces and Motion. Our topic is Newton's second law now. So what's Newton's second law? The acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the mass of the object. Or I can simply say summation of forces, it means net force equals mass times acceleration. Forces are vector quantity, acceleration is vector quantity. I can say that acceleration is force over m. When can I increase the acceleration of an object? If I increase the mass applied, the force applied on that object. Like if I have, for example, a tennis ball, I need to apply more force in this tennis ball. I hit this ball with more force, the ball will accelerate faster. It changes its velocity and acceleration will be higher. If I use of the tennis ball instead bowling ball, a heavy ball, and I applied the same force on the bowling ball, it has a huge mass, the acceleration will be less. So the relationship between acceleration and forces are directly proportional, increase. This is what directly proportional means. The relationship between acceleration and mass are inversely proportional. A huge mass with the same applied force, it means less acceleration. How can I choose Newton's second law to solve problems? You remember the steps we used for Newton. Let's recap the steps for Newton's first law. I told you always use these steps whenever you want to solve problems that is related to Newton's law, whether first or second. First, you have to write and check the given. Are the given units consistent or not? Draw free body diagram. Free body diagram, it means all the forces acting on the object. Determine the direction of motion. Which direction the object is moving, the direction of acceleration. And then you have to know that the forces that are in the same direction of motion is positive, while forces in the opposite direction are what? Negative. Make X and Y table. Write the component of forces in X direction, the component of forces in Y direction, and then apply Newton's first or second law, which is summation of forces equals mass times acceleration. Okay, let's solve the question. Here I have a blue box. Mass is 5 kilograms, is pulled by 100 newtons. So this is the applied force. The coefficient of kinetic friction 0.5. So this is a mu k, kinetic or dynamic. And I need you to find the acceleration. Here I applied force, so the direction of motion, it will be the same as the direction of applied force. This is the direction of motion or direction of acceleration. What are the other forces acting on this object? From the middle of the object, I can draw gravity, weight of the object, and here normal to the surface. This is the surface I have, Fn. In this case, opposite to the gravity. I finish with a free body diagram. My units are consistent. I have kilogram mass in SI unit. I have 100 in Newton SI unit. I don't need to convert anything. Second step, what should I do? Forces in the direction of motion are positive. So this one is positive. Opposite to the direction of motion is negative. Then, what is the other step? X and Y. So here I have X and Y component for the forces. I'll start with Y because I don't have motion in Y direction. So that means it's Newton's first law. Summation of forces in Y direction equals what? 0. What that means, this is equilibrium or balance. The forces are balanced. All the forces up will equal to the forces down. How can I find the gravity or weight? Is mass times g. Consider g is 10. 10 meters per second square. So mass 5 times 10, I will have 50 in Newton. So Fn will equal 50 in Newton. Here I have motion in x direction or in the horizontal. It means horizontal. Sorry, yes, horizontal. Y, it means vertical direction, vertical. So since I have motion, it will be Newton's second law, summation of forces in x direction or horizontal direction will equal ma, mass times acceleration. If applied is positive, which is 100, minus friction force will equal mass is 5, acceleration, I don't have it. I need to find it. So 100 minus mu k, I know if k, it's mu k times Fn, So I can apply mu k, it's 0.5. Fn is 50, will equal 5 times A. Divided by 5, it will give you A. And if you calculate this number, you should get 15. Acceleration will equal 15 meter per second square. I want you to revise Newton's third law as well. For every action, there is opposite and equal reaction. If I apply a force on a wall, the wall will apply a force on me in the opposite direction. Also, I want you to revise for the assessment. How can you find the net force? If you have the forces are in the same direction, what should you do? If the forces are in the opposite direction, also what should you do? If you have forces that acting on the object and these forces are in, let's say, perpendicular, what should you do? All of these, I want you to revise them from your class note. Like, for example, if I give you here, this is you have an object and you have forces, two forces to the right. One force is 5 and the other force, let's say, 8 Newton. And I have another force to the left, let's say 2 Newton. Find the net force. To the right is positive, to the left is negative. So net force, it would be 8 plus 5 minus 2. Minus 2, and if you get this, it will give you 11 Newton. If you have two forces, and these forces are perpendicular, like I have an object and I apply a force toward east. F1, for example, is 12 Newton toward east. And then on the same object, I apply a force north on the same object, F2. How can I find the net force? Force is a vector quantity. So from where we start to where it ends, this one is the net force. Here I have perpendicular forces. How did I know it's perpendicular? Because north and east are perpendicular. North and west are perpendicular. West and south are perpendicular. South and east are perpendicular. So we're going to use what? Pythagoras theorem. F net will equal square root F1 square plus F2 square. And then you can determine the direction. Theta, if I'm using theta here with the east direction, so it will be east-north, the direction of net force, it will be east, north, and you can find the direction using tan inverse. Opposite, in my case, is F2 divided by adjacent, which is here F1. Can I use the other angle? Yes, but in this case, the angle will be what? Will be from north. I'm measuring the angle from north. So it will be northeast, the direction, northeast. Here is east-north. Good luck for your assessment, and have a great day.